actually autonomously drive a car. So which means you can just expect your phone to be able to take enough decisions and fast decisions to be able to safely navigate through traffic and take you home, right? So that's the amount of processing power we have. Now, as I speak through this, you can see that it's not just about electronics, it's not just about mechanical, it's not just about software, but it's a lot about user experience. It's a lot about fundamentals in science. It's a lot about materials. For example, batteries, the kind of packaging that you use, all the way from the material that's used for the skin, and also optics, kind of camera we talked about. It's an optics. So there is a lot of materials that go into it. There is a lot of optical engineering that goes into it. There is a lot of sensing technology that goes into it. And you have these wireless charging, which has a lot more in terms of electrical design, not less electronic design. And there are a whole bunch of engineering domains which have to work like a well-oiled machine together to make this happen. And not to mention the wireless technologies, the RF that we take for granted. And if you turn around, you see the brilliant display that's there, which represents a lot of material and optical and electro-optical designs that go into it. So it's no longer a single domain which is capable of bringing about this sort of a product. But if you have to look at this sort of a product, you will have to basically look at the confluence of many disciplines, many interdisciplines which come together, work hand in glove to make this possible, right? And similarly, look at a notebook design. So a notebook and phone designs are not very different. They're quite similar. However, the complexity is manifold because you expect a lot more from a notebook. There are a lot more peripherals that are there. There are a lot more computational power that is there. And a lot of components that get packed into it. For example, the 22 billion transistors that are packed into an extremely small, it's almost like a thumb size die, which actually contains this many transistors, right? I mean, it's unbelievably complex. Now, all of that was possible purely because of the advances in optics, because that's what makes our silicon manufacture possible. Advances in materials, like for example, semiconductor materials, the doping materials, a lot of advances in manufacturing, a lot of advances in process, a lot of advances in packaging, product design, chemistry, user experience, user study. I can go on, right? So there are many facets. We'll look at them in the next few slides. But then I just wanted to bring about as to what it takes to bring about this sort of a power-packed machine, which we have taken for granted today. But then this just represents as to how the pace is and how the industry is shaping and evolving. And that's where we need to change the way by which we start looking at engineering. So with that, let's go look at what are the different engineering facets that are at play. What are the different domains that are at play in a typical product design? See here, I'm showing a MacBook Pro, which is a laptop from Apple. And if you look at it, you can actually see a whole lot of engineering domains that are involved. I mean, this is just a subset. It's not the full superset of all the domains that are there, but these are the critical ones. We'll start with mechanical engineering. So mechanical engineering is responsible for packing all the components that are there. Within that components includes the motherboard, the keyboard, the display, the cables, the batteries, and everything that goes into it. And not to mention your speakers and mics and everything that you expect of a design. And there is an industrial design, so you just can't take a box and then put all of these together and expect that to sell. There is a beauty in the way by which the product is designed. Every curve comes within the product has a specific theme. So if you look at all the laptops that are coming from Apple, they look very similar. All the laptops that are coming from HP, they look similar and they have a design theme. And people go by the theme. People go after what Apple sells in some industrial design. And Apple was the first who actually brought about a revolutionary change in the way we look at industrial design. And electrical design is I mean, no cases here, right? I mean, electrical design has seen growth in leaps and bounds. When I say electrical, it includes both electrical as well as electronic design. So on a laptop, on an average, you have about 28 different power rails, and each one of these rails have to be extremely efficient. We're talking about 90-95% of efficiency, in terms of conversion between different rails. There comes your electrical engineering, and then you have a speeds well in excess of 5 gigahertz. The core CPU operates at 5 gigahertz. You have RF frequencies which are at 60 gigahertz. So you have the entire spectrum of electronics engineering which has to go into it, right? And that's a huge in terms of how you actually what kind of engineering goes into it. And similarly, software, right? I mean, user experience, software, so everything has changed. So today, there's a lot more artificial intelligence and machine learning built into it, even without our knowledge, than what was there even 5 years back. And the trend is changing, right? And it's accelerating. So neural networks, machine learning, artificial intelligence are the buzzwords in the software industry. And I will not be doing justice if I don't talk about the advances that are happening on materials, right? I mean, everything that you touch and feel, to the battery, to the keys, the plastics that go into it, the displays that are there, the kind of chemicals that are going into the displays, the materials that are used, everything has seen a phenomenal change. So is the case with sustainability now. Sustainability is the next big wave. We'll talk about it shortly in the next slide. So there is, I mean, you cannot keep mining and refining and extracting materials and minerals from the earth forever. So there is a limited amount of resource. So there is a huge push towards sustainability and how we actually design products for it. And similarly, when you design a product, you have to test and validate. So there is a huge engineering aspect. There's a huge engineering domain that's aimed at looking at just at validating and testing the platform and the system as it comes together. And one of the key areas which we generally overlook is the user experience. So when you say user experience, when you use a product, what's the experience you get? So are you happy with the way that the device interacts with you? Are you happy with the way by which the device fluidically changes and expects your command and responds to it even before you give a go ahead? So those are the kind of user experiences that matter a lot. User experience also includes ergonomics, the way that you use, even the tactile feel of your key. That's engineered, right? It's not something which is just happens. It's engineered. So thermal engineering. So you are looking at extremely thin systems which are as like 3 mm or 5 mm, which are thinner than some of your phones, and you are packing in close to about 60 to 70 watts of power, right? So enough power for more than 3 soldering irons. That much amount of power is continuously being dissipated within the system. How do you cool it when a laptop is supposed to be kept on a lab? So how do you prevent the laptop from burning the user, right? So that's basically the fundamental behind thermal engineering. All of this is fine, but if we cannot manufacture it, we cannot manufacture it in billions. So then it all falls flat. So there is a huge amount of effort that goes into manufacturability. And the first thing that strikes is when you look at a product is the display, right? I mean, the emphasis of display and optics cannot be underemphasized. So we've taken, as we saw before, we have started interacting with the systems in a different way. So which means your audio, speech, sensing, everything is different. Now, all of these are not individual domains, right? So these are domains, of course, from an engineering standpoint, but when they come together, they all have to interwork with each other. For example, a mechanical engineering, you cannot just go and put a battery without having the clearance of the electrical engineer or the electronics engineer who's going to place a motherboard. Because the motherboard is going to sit right next to the battery. The battery has got a specific volume which has to be maintained. It has a specific mechanical strength. And all of this has to fit within the outline that the industrial designer has given. Right? So that's basically how all of these are extremely intertwined. And same is the case with your user experience. When you talk about user experience, you talk about keyboard, you talk about key travel, for example. So there is a specific amount of travel, when you say travel, the amount of distance that a key travels before it makes contact, right? So those are specifically designed with the user experience. So come and say that, okay, I need 1.5 mm of key travel before the key sense, before the key gets sensed. So now the 1.5 mm is the user experience. That's basically engineered, which means you need to have a specific thickness of the keyboard which goes within the system. Now the moment you put a keyboard there, right below the keyboard there is a battery, there is a motherboard. So now there comes all the interdependencies. Now my basic idea with saying all of this is that these domains exist, but when it comes to product design, they are all highly interdependent. And as an engineer, so if you are a mechanical engineer, you are expected to be extremely good at what you are doing, but at the same time, your success and the product design success depends on how much you are able to appreciate and understand the requirements of other domains, and that is where the whole of interdisciplinary action comes in. I will explain this a little more in detail in the next few slides, where I will go through a practical example as to how in Intel or as a matter of fact any product design company does that. That will basically make it a lot more intuitive for you. But then here is where the lay of the land is in terms of what are the different domains. And this is a very typical product. It's not just about a laptop or a phone or a PC, right? It's also about any product that you take out in the market. May not be so exhaustive in terms of the number of domains that are at play, but they are all multidisciplinary for sure, right? So here is a fun way of how you're given challenges. So I mean, this is not to the level of for people to know about as to how Steve Jobs used to give challenges to his team, but it's pretty much there in different forms and vectors, different companies. So as a team, so my team was basically given up a challenge. So the challenge was go and design an all-in-one. And all-in-one, for those people who may not be knowing about it, is all-in-one is a PC, it's a desktop which has a display, a keyboard, a mouse, and a compute all put together in a single system. So that's basically what it's called, an all-in-one, right? So an all-in-one PC was a new PC which was starting about 8 years or 10 years back. So this is a 5-year-old story by now, but it's still relevant, and it's a yardstick of how it generally happens in the industry. So on the top left is how a traditional desktop looks. So we are all aware of the traditional desktops. That's how it looks in your labs, probably in your home, when you have a desktop or a gaming system. So if you can relate to it, it's about a 35 mm display, which is about 1.5 inches. The entire thing weighs 10 to 12 kilos, which is as much as a gas cylinder. And it's a mess of wires, it's a tangle of wires, right? That's how the traditional desktop is. When you look at how you think buying a desktop, that's the first picture that comes into mind. Now, Intel wanted to change all this, right? Intel wanted to shake up the PC industry. They wanted to bring about, I mean, we were getting inspired with Apple, right? So Apple brought about the importance of again industrial design. So wherein it's not just about what a vehicle performs or a car performs, right? I mean, it's also about how it looks, what are the kind of features that it has, what are the creature comforts, what's the economy, what's the cost. So everything comes into the picture, and same thing applies here. So Intel wanted to shake up the PC industry. We wanted to bring about a revolution in the way we design and look at how the PC is without compromising any of the performance. And we wanted to bring in portability. I mean, portability and a desktop, they are not synonymous, right? But we wanted to bring about portable design. And it had to have a brilliant display, right? And a phenomenal IT. So now we started with a clunky desktop, which was weighing tens of kilos and was 35, 40 mm thick at its thinnest point, and pack all of that into the world's thinnest all-in-one. So the world's thinnest all-in-one, just on the bottom right, we call it the Starbuck. You see a lot of videos in the YouTube if you want to look at it. But this was the all-in-one that our team with, right? And it's just 10 mm thin and extremely light. It's just about 2 kilos. It's a 24-inch display, has all the performance of a traditional Dell power phone, and will talk of connectivity on. So this is what the team ended up designing. Now, if you were to go back and then look at how did Steve pull it, that's basically what the interdisciplinary skill is on at play. Right? So that's where the entire interdependency of all the domains comes into the picture. So let's go back to the problem. Now let's ask the same question that we asked many years back, right? So I mean, what makes all these desktops and all-in-ones so thick? why are they so thick? Why should they be so thick? Right? So we started looking at what are the different areas which are contributing to this thickness. And quickly we realized that okay, there are two main areas which requires a phenomenal re-engineering. Right? So when we talk about re-engineering, that means it's grounds of design. So the two areas being display. So display was the biggest, thickest, heaviest component in an all-in-one model desktop. And the chassis, when I say the chassis, that means the mechanical enclosure which holds all the electronics, the cables, everything put together. So we realized that these are the components. So we said, okay, what does it take to make the display thinner? And when we looked at it, we had to go into and say, okay, optics, which means the way that the light is passing through the anti-glass, the way the images are created. So that's the optics part. Then there is materials part, which means you need to go with thinner materials, you need to go with materials which are capable of using brighter image or bright color without changing any of the other characteristics. You have to look at adhesives, which means again materials which are holding all of these together, and not to mention the electronics, like the kind of processing that's needed, the kind of packaging that's needed, the miniaturization that is needed, and the entire process for making all of this. Now, if you were to divide these into two domains, so these would be different engineering domain by themselves, right? But when you say the problem, so when you look at the problem as such, it's a discipline, so you have to go solve it, which means all of these domains have to come together. They have to work together. They have to look at what are the engineering challenges and then sit and solve. Right? So that's just for the display. Now, if you look at the chassis, which is the enclosure, you have a huge dependency on electricals. You can't have a huge motherboard and then expect the chassis to be smaller if there is motherboard spilling all over the sides, right? So you need to have the electrical motherboard and the electronics, everything miniaturized. You need to be able to manufacture it because you're going to sell in millions. You need to again look at materials because you're now putting a battery there, you're putting a cable, which is a different material. And you also have to look at how is the silicon, that is the integrated circuit, or the microelectronics, how are they miniaturized? What kind of user experience are you looking at? I mean, this is a thin all-in-one, it's a world's first. So people are expected to carry this. What kind of user do you want to put this on a wall? Do you want to put this on a desktop? Do you want to put it in the front office? What kind of user experience? What kind of audio experience? What kind of speech capability do you want? So all of these come into the picture, and all of these are interdependent. So you cannot design a chassis which does not have enough openings for the mic or the speaker. You cannot design a chassis which does not have enough space for a battery. You cannot design a chassis which does not have enough mounting or enough provision for the electrical motherboard, and you cannot have a chassis which cannot have a sufficiently big thermal cooling solution, which means you're putting an extremely powerful system within a small enclosure. So you cannot design a chassis without taking into account how it is going to be cooled. And you cannot define user experience and usages without considering the software complexity, whether the software is capable of doing it, and also are there enough sensors which can identify and react to the way that you put the system and expect the system to work. Now, these are all interdependencies, and these are all domains which have to work together. And only when you are bringing all these together and trying to solve a problem, the common problem being getting an extremely thin, very attractive, extremely high performance thin system, right? I mean, this is just an example. I mean, this does not just apply to PCs, it also applies to any product, as a matter of fact. I'm just taking examples so that you can relate to it in everyday life as to what is a desktop, what is all, and how to look at it. Now, were we successful? Of course, we were. So, the result of our interdisciplinary work resulted in well over 35 patents. Right? It's still, even today, it is even after 5 years, it is the thinnest, the most powerful all-in-one in the world. It's portable, 24-inch, extremely colorful screen. It's not RGB for the people who appreciate it. It's a complete grounds up approach in terms of how you manufacture, how you design it. It's not a traditional design, and that's where innovation comes. So all of this basically resulted in millions of units sold. It became one of the most most successful all-in-one designs for Intel, and it's just one of the many examples. Now, the reason why companies like Intel, Apple, AMD, Qualcomm, all of these are able to flourish is basically because of the fundamental fact that it's not just about raw engineering or raw engineering horsepower that is there, but it is also about the, the gross amount of interdisciplinary interactions and engineering activity that goes. And that's what I would like to highlight here. So there is no innovation without all of these domains coming together, right? So with that, let's go look at, okay, so this is the current state of art. So now, how does it look? What's the future? And what do we expect? And what do we gear up for? And for brilliant young engineers like you, so what are the different trends in product design that you need to be aware of? So for sure, I'm sure most of us would have realized that that controlling through speech, gestures is going to be something which is going to be more and more prevalent. It's not just restricted to our phones, but it is also going to be our TVs, our washing machines, and our refrigerators and our ovens and everything, right? So it's going to be like omnipresent. It's also going to get much more interactive. A lot of vision-based decision making is going to be happening. You have seen that trend already happening on the vehicle industry. You have started seeing this in some of the security industry. You have started seeing this in the manufacturing industry. You'll start seeing this in the regular households as things go by. In the future or in the near future, we are expecting a lot of sensor integration to happen. So it's not just about just like a temperature sensor or a pressure sensor, but different kinds of sensing. For example, brainwave sensing, electrocardiograph or electroencephalograph sensing, sensing by means of touch, by means of gesture, by means of blinking, by means of eyes, by means of facial expressions. All of these are new methodologies by which there is a trend in product design which is happening as you speak. Now these are basic engineering, but then there is another level of a superset which is also taking over, which is in terms of machine learning. So you are expecting a lot of machine learning today. Machine learning is happening at the server side, which is not very common at the user side. Then you start seeing a lot of this machine learning where machines can learn as to how you use them, how you interact with them, and behave accordingly. So which means a lot of software goes in, there's a lot of hardware that goes in, there is a lot of new sensing that needs to be done, there's a lot of thermal cooling, there's a lot of processing power that needs to be packed in. And that's basically going to be the fundamental behind enabling machine learning at common man level. You're looking at a superset of machine learning, which is artificial intelligence, getting into the picture. So today we have very, very restricted areas where AI is prevalent. But then you start seeing this coming everywhere. It's in terms of how your system interacts with you, how it knows your preference, and helps you with your everyday code. Now, the last two are more to do with the current changes that are happening around us, right? So, be it the work from home scenario, work from anywhere, or something which is happening, like for example, at a much more global scale. Not to say that pandemic is not a global scale, but something much more, far more outreaching, which is like the global warming and climate change. Now, these are trends which are going to be changing. We'll be quickly looking at the sustainability part of it because that's another big trend which is happening. That's another area where there's a huge opportunity for a lot of interdisciplinary skills at play there, right? So we'll talk about that. So these are the general trends. I'm not saying that these are the only trends, but these are general trends that you will start seeing in product design. Now, is there a single engineering domain that addresses this? Or addresses this? No. It's a confluence of multiple domains coming together, and therein lies the importance of interdisciplinary nodes, right? So let's look at the next few areas which also have a lot more potential, right? So some of you might have seen or heard about carbon footprint, sustainability, green energy, carbon neutral computing, and like reduction of energy wastage and all of that. look at it, that's another huge area where every country has committed towards sustainable development. So the UN has set a certain set of 17 goals to transform by 2030. And pretty much every country and every company there, including large multinationals like Intel, have committed towards making positive change towards it. And there is a big uh, change which is required, which is in terms of how you design and what you design, because every product that you design has a specific carbon footprint, and that is where a lot of these change in terms of how you design, not just how you use it, is coming into the picture. Right? So this is about sustainability. So just to give a snapshot, I would like to just quickly run through this. So just to give an idea of what is the 2030 goal translated to engineering, right? So when you look at on the left is how we call as what is called as a linear economy. So when you say linear economy, you just make a product, you buy it, you use it, and at the end of its life, you basically throw it. So it's a linear economy. Now, linear economy is how we have been designing and using our products till date. There is a little bit of an effort where you try to recycle. That's basically caught up in certain areas of our society, not just here but across the globe, wherein you are trying to recover, say for example, plastics that you're using for packaging, the cardboard that's being used for packaging. So wherever possible, we are trying to recycle it. But then the real goal, that is the 2030 goal, which is what UN is asking every one of us to do, is that we go towards what we call as a circular economy. So when we say a circular economy, that means you design a product where nothing is going to waste. You design a product where everything is recycled. You design a product where everything has zero net carbon footprint. Now that's a very tall ask. It's a very tall order. Now that is where the challenge. That is where. So we don't. I mean, we know as industry experts and leaders. Does the industry know? Does the organizations know as to how to do it? Absolutely not. That's where the opportunity comes with engineers, young engineers like you, where you can come up with fresh new ideas. Opportunities are there where you can actually go and make a difference. And now all of this is not just about a single engineering, as you see on the left. It's not just about a single electronic motherboard, change it, and then voila, you got a earth change, you got a earth shattering change. No, that's not about how it happens. You need to be aware of how all of these engineering domains come together, how all of these different processes and manufacturing happens, how the products are designed, and you'll have to encompass all of them, right? And that's basically where the next change in product design happens. So what we spoke till now was how we interact with the product, how we use the product. Here is what we are talking about, how we are going to design. So it's a paradigm shift in the way fundamental product design and thinking happens. And that's basically what sustainability is all about. So it's about reducing the amount of wastage, it's about reducing the amount of material usage, it's about the reduction of dependency on freshly mined minerals and chemicals. It's about reduction in energy emission, energy usage and wastage. And it's more about reuse, wherein you are designing for a system to be repaired in the field, you're designing for a system to be modular, you're designing for a system to be reused with minor modifications or little modifications. And then at the end of it, you're also designing it for recyclability, wherein you have a product which is designed for absolute recyclability. And you have a product which can be recycled without big economic impact or with a huge environmental impact. And therein, all the ingredients come back and manifest themselves as the next generation of products for the next generation of people, right? So this slide basically represents a paradigm shift in the way products are even thought of, what products are designed. So if you look at, this is a very good example where it's not just about one domain of engineering coming in, but it basically has an impact across the board, across all domains of engineering. They all have to interact with each other. Solutions are not just about using specific set up screws instead of another, but it's up whole thing is put together and the entire way by which the entire mindset is, right? So that's basically how the trend is in terms of sustainability and product design, right? So just to quickly wrap up and quickly come together towards the end of session. So here is where I would like to wrap up with a set of opportunity, right? So the fundamentals, just to reiterate, the fundamentals of engineering have not changed. They are not changed in decades. They may never will. But way products are designed is changing. Be it the way that you're using it or the way that you're designing it, the way that you are even or thinking of a product, that has changed. That has changing, right? Expectations have changed. Now, if you're going to go and if you're trying to buy a phone, the expectation is that you're not just looking at it as a phone, you're also looking at it as a camera, you're also looking at a storage device, you're looking at it as a social media connect device, you're looking at it as a display for content consumption, you're looking at a content creation device. So the expectations are different. So the expectations are ever changing. So which means you as a customer and you as a designer, both, right? So today, pretty much every product that you're looking at, it's not just being designed for a single purpose. So every product has a multifaceted avatar to it. So which means that makes them extremely complex. For example, a phone is a very classic example. A car is another example where you just don't sit in a car just with the expectation that you go from A to B, but you also like to be traveling in comfort. You also would like to go there on time. You also would like to have less carbon footprint in the process. You would like to go there fast. You would like to go there in luxury. You would like to have all kinds of entertainment while you're traveling. So it's not just about a single purpose, but about multifaceted expectations and multifaceted domains coming into play, right? So all product designs have interdependencies, so which means multiple domains of engineering have to come in. So what is the opportunity here? So you as an engineer, it's not that you start training yourselves. If you're a mechanical engineer, you start looking at, okay, I need to take some additional courses and then start designing like an electrical engineer. That's not the point. But the point is, you as an engineer be cognizant of the fact that it's not just about pure mechanical or electronic or electrical or software engineering that's going to be differentiating you. It will definitely help you if you have a broad knowledge base, right? So it's critical that you have a broad knowledge base. It's critical that you have a good understanding of interdependencies. When I say interdependency, when you're designing, say, for example, a mechanical product, so it's not just about mechanics that's going to be involved. It's also going to be like dependency from other people, like engineers who are electrical or software. So they're also going to have interdependencies, right? So a good understanding of their interdependencies will help reduce production, will help reduce the time to market, will also make sure that your product comes out really good and well thought of, right? And you as an engineer, so yeah, the opportunity is to be willing and open to accommodate, learn, adapt, and apply. So when I say accommodate, that means accommodate other domains of engineering, learn what other domains of engineering are, what are the interdependencies, adapt to the ever-changing environment in terms of customer expectations, in terms of competition, in terms of how the products are being designed, and apply all of that you're not the knowledge that you've gained, apply that to your product design. After all, engineering is all about application of science, application of knowledge, right? So that's the expectation and that's the message that I would like to give, and that's the opportunity that you have, right? So with that, I would like to summarize just to read through as to just to summarize in a few bullets as to what we discussed so far. So the boundary between disciplines is fast evolution. So there is no clear cut, single, chalked out engineering domain that exists today. So there are a lot of these interdisciplinary mingling that's happening. The boundaries are diminishing, right? I mean, there is no mechanical engineering without electrical, there's no electrical without electronics, there is no electronics without silicon, there's no silicon or process manufacturing without software, and so on, right? So the boundaries are diminishing and it's fast. there is a lot of increasing level of interdependency. The reason why that is because the product designs are getting complex, the user experiences are taking a front seat. There is a lot of expectations from the customer there, and there's a lot of competition. So there's a lot of interdependency as a matter of fact. That's basically stemming from all these factors. Innovation is all about making the right connections between different fields, and that is where the opportunity is, and that's where innovation happens. So when you see a problem and you cannot solve it in the traditional way, you try an unconventional approach. That's what is innovation all about. Now, where do you get that sort of inspiration? Is when you actually have a lot of interdisciplinary exposure and the ability to accept and adapt to all of these new fields of engineering. That's basically will give you the ability to innovate. So engineers, we as engineers, so I'm hard an engineer, so we are all professional knowledge workers. So our success in the industry depends on not just what we know, but also how we use them, how we put our knowledge to good use, and how we put our knowledge and experience to design product, and how we keep learning, right? And innovation is the key to survival. So that's basically how companies like, for example, Intel has become a multinational giant with assets well exceeding that of a few countries, for example. And being deep in one's domain is not just sufficient anymore. So you need to have a broader understanding and appreciation of the interdependencies and embrace that. That will be crucial for your success, right? And with that, I would like to thank all of you for your time. And that basically brings about an end to my session. So any questions or any interactions that you may want to have, this will be the time.
Thank you, sir. Thank you very much. It was a splendid lecture about how the interdisciplinary works in innovation. Guys, if you have any questions, please you can put forward. Sir, it's a common question they have students. How to get place in these intel because these companies are the dream companies for them, but they doesn't have a proper channel how to go, how to approach because they think that so we cannot go only tier one colleges can go there because they are not coming for
But it's not about. I think. Yeah, there is a common misconception that the tier one colleges actually get or students from the tier one colleges get an opportunity. That's not right. What is actually true is the level of knowledge and level of depth of knowledge which is there, which is present in the candidate, which is actually the differentiating factor. So gone are the days when we used to have only the IITs and IIMs being looked at. In fact, in our team, in my team, there are close to about 300 of them. A bulk of them were from tier one colleges. I mean, they are basically from pretty much all domains. And there are a lot of freshers whom we hire on a regular basis, and we hire not on the basis of what college they come from, but on the basis of what they know. As I said, we are all knowledge workers. So we are looking at what is the engineering maturity level of these engineers, what's the level of passion that they have, because these are product design companies. And you cannot learn unless you have a passion for learning and passion for doing engineering. So that's basically what differentiates. So that's a common misconception. And I have hired and I have been a manager for close to about 12 years. I've managed hundreds of people. That's basically not the criteria. The criteria is what I said. Right? So it's about what's the level of passion, what's the level of uh, interest and depth of knowledge and capability that the engineer brings in, right? So that's basically what is expected, and that was the basis behind me coming and giving this thought process, wherein it's about how you look at domains. It's not just about just applying or taking a few instances and saying that okay, I'm a mechanical engineer and I'll be a mechanical engineer for life. Uh, it's not just about that, right? I mean, it's about embracing, and it's about adapting to the changes. That's basically what decides as to how successful you are.
Yeah, thank you, sir. Thank you, sir. Thank you very much. Yashwant, you can go with any questions, ma'am? Any questions, you can ask, or you can wind up the session.
Feel free, guys, or reach
Feel
out to
free.
me. Yeah.
Jyotish, you can go with the question. Actually, sir, Aravind, I want to introduce him. He's a guy going with all mobile apps and everything. He's having a passion of going with the tier one companies, or he want to go with only with the high package. But what is the hindrance he's having that he's an innovative student here. He brings many prizes in MHRD member also. As for our college, he's working on the project. He had a group of students here near me. They do all these sort of works. But the only thing is they want to go with the higher package salary. They will not go with the lower package. They have that thing. But what I am saying is, I don't know whether it's correct because it is in my academic review. I am saying that whatever company is coming for you, get an experience and you can switch it. Don't imply that you have to go in this thing because we cannot climb the thing, the wall to the top at the first time itself. So I am saying that, but I don't know about your perspective, so you can even guide them in that way also.
Yeah, I mean, you are right, Dr. Padmapriya. So the thing is, ultimately, experience also plays a crucial role. It may not necessarily be. So one of the days when in the 90s, in the early 90s, when there were just a handful of companies. In fact, when I think Dr. Padmapriya might be able to relate even more, in the sense that when we kind of came out of our colleges, there were only a very few companies where we could look up to, right? And so we did not have the breadth of knowledge, breadth of experience, or even the ability to go and gather these. Things have changed now. It's a lot more different than what it is today, and the change is accelerating. For example, you have pretty much uh, every big company is out here in India, where they have not just a sales outlet or a marketing outlet, but predominantly a design outlet, right? So gone are the days when you have to travel abroad or go into some other country to actually get the experience or knowledge. You get a lot more experience and knowledge working right out of your backyard. That's one. The second aspect is you don't necessarily have to be in big companies. Sometimes going into big companies may not necessarily give you the right level of exposure. You might end up being in one domain which may not be your area of expertise, or it may not be your passion, it may not be the area of interest. So it's not just about the package that you get right at the beginning, because there is a steady set of growth in remuneration, which is set as a rule, which is a hidden rule, but it's a rule which is there within the industry. That you might actually start with an early initial bump, but then as you go towards the later half of your career, you may not be able to see a big jump in your salary stream growth, right? That's one. The second aspect of it, it's not just all about money. It's all about experience, because ultimately you need to be employable at every point of your career. So it's not just. I mean, private companies and big companies, they are not like government organizations wherein you go there and get settled for life. That's not how it is. You have to constantly evolve. You have to constantly learn. You got to constantly keep pace with the technology. Otherwise, it's going to be very difficult to survive in the industry. And there are a lot of examples where we have had people who drop out because the pace of change is way too much for them to take in. So it's not just about coming in and then settling down. It's not a government job wherein sorry to take that example. I didn't mean to say that it's bad, but it's not about settling down for life. It's about learning all the way. We have people who are working well into their 70s, and I've had the fortunate good wish, good luck that I've actually worked with some of the pioneers. For example, Ajay Bhatt, who invented USB, I've worked with him closely, and so are the cases wherein you get an opportunity to work. But at the same time, the market has changed. There are a lot of startups. You look at some of the big companies and countries that are coming in. In fact, if you look at pretty much all the companies that are big today, like Google and Apple and Intel, they all started as a very small shack, right in the middle of a shack or in the middle of someone's garage. They started this. And today we are looking up to these companies, but they all started in a very, very humble manner. So, in the sense, what drove them is not a package which someone offered, but it's about the passion which helped them grow. Right? And that should be what should be driving you rather than looking at what's the package that a company is offering and what is which company gives me big. That's not how it is. If it is a small company and your earlier point of your career is extremely critical, because that's where it actually shapes the way things are to come in the future. Because as you grow into your career, as you start maturing in your career, changes will be far and few between. So the early phases of your career is the point where you can actually make an experiment, start looking at because you have a lot less dependencies, you can learn a lot, you can change a lot, and that basically is the time for you to go and explore, not to be bogged down with just looking out for a specific pay package or a brand or a title. It might give you the kicks initially, but then it will settle down, and it may not actually be worthwhile in the long run. So, what will keep you going for decades, if that is what you want, then you put your foundation and fundamental strong. I think that's more critical.
Yeah, thank you. You have given a clear picture for them because you are all interdisciplinary students, others, so it will be useful for them to go with their career. Any questions?
Hello, sir. It's me, Jyotish. And I have one question, sir. If I am doing an innovative project, will it the same company or the similar companies, the similar technologies I am doing in the project?
Yeah, sure, I'm not able to hear you. I'm sorry, your voice is breaking up. Can you speak louder, please?
Hello, sir. I am speaking Jyotish. Yes, sir. I am doing a innovative project. Will the which is like a similarity of an for a company, which it has an upgraded thing. Will that company will sponsor my innovative project, or how to approach the companies to sponsor my project or incubate my project?
There are people, I mean, there are opportunities where you can, if you're looking at just funding or incubation, there are different opportunities and vistas. For example, angel funding and venture capitalist, whom you will have to go and look up for funds. If you generally look for a company, unless the company is into incubation of these technologies, it's going to be very difficult for them to come and sponsor or fund a particular product unless the product that you are developing or designing is in line with what they are working on, or is in line with what they are trying to develop, or they see some sort of a financial benefit in you developing the product for them. For example, Intel has a specific financial outpost within ourselves, which is called the Intel Capital. So Intel Capital does go and invest in a lot of startup companies and startups which are basically working on different technologies which are relevant in the PC business. So if you are working on something, for example, in rocket, then there is very less likely chance that Intel will come and fund. But however, SpaceX or Skyroot might be interested, right? So it depends on what you are working on, what is the need, And don't go by when you decide on, say, working on a product or a project. Don't look at it from your perspective. The first thing that you have to understand as a product designer is that you have to look at, is there a demand? Are there people looking for it? Is there something that people will be interested in buying it? If so, who are the people who are interested in buying it? And who are the companies who cater to those customers? Now, if you approach those customers, those companies which are catering to the same customers to whom you are developing the product, there are high level of chances that you will get a sponsorship from them, or probably an outright buyout, or probably a limited investment, whichever be the case, whatever the deal works. That is where building a good portfolio of successes in your profile is very critical for your success.